Now we are going to discuss question number 5.34 and my dear student, again this is a actually conceptual question, so concentrate on a screen. Two bodies are given to you, body number A and body number B. This is given to you and it is having mass 5 kilogram and 10 kilogram in contact with each other, rest on a table against a rigid wall as shown in figure. Clear? So my dear student, you can see here we have two blocks, block number A and block number B. Clear? Now actually we are exerting a force 200 Newton on block number A and it is actually placed against a rigid wall. Clear? This is given in a question. Fine. So the coefficient of friction is also given to you between table and the blocks. Okay. Now our first objective in this question is to calculate the reaction of the partition. Clear? So now listen carefully. Now listen carefully. Let's suppose if I am talking about part number A. Clear? We can say here an external force 200 Newton I am exerted on block number A. Clear? And now let's suppose first I am assuming A and B as a system. Clear? What I am saying to you, A and B as a system. So first can I calculate total value of friction force exerting between block and the table? Yes. So I can say first I am calculating friction. Friction is given by mu times of n, mu n. N is what we can say normal reaction. Normal is given by total mass of these blocks and multiplied with G. So I can say here we have Ma plus Mb and this is multiplied with G. Clear? So coefficient of friction is given 0.15. Masses of blocks are given to you 5 plus 10. So 5 plus 10 and this is multiplied with G. So I can say G is given to you 10. Clear? So 1.5, this is multiplied with 15. Clear? So now we can say this is equal to I can say this is equal to 22.5 Newton. Clear everyone? Yes or no? We can write like this: 15 multiply 15, 225 and it is divided by 10, so 22.5 Newton. So I can say when I am exerting a force 200 Newton on these blocks, friction force is acting towards left direction having magnitude 22.4. Clear? So now we can say this system is at rest. Clear? This system is at rest. It means definitely I can say one normal reaction is exerted by this wall on these blocks. Clear? So I can write like this. 200 Newton. This should be equal to friction force plus normal reaction. Clear? Friction force given 22.5. So I can say 200 equal to 22.5 plus normal reaction. Clear? So I can say normal reaction is given by 200 minus 22.5 and I can say this is equal to what? 177.5 Newton. Clear? So I can say this is a normal force exerted by rigid wall on this block. Yes or no? Or we can also say every action has an opposite reaction. So same force is exerted by block on this rigid wall also. Clear? It means first part is clear to you. The reaction of a partition is equal to 177.5 Newton. Clear everyone? Now we are going to discuss part number B. Clear? In this question it is given the action reaction forces between A and B. It means now we have to draw free body diagram of A. Clear? Either A or either B. So let's suppose I am concentrating only on A. So at that time I can say, let's suppose if I again draw here figure for A, I can say 200 Newton force is acting. Now I will calculate here friction force. Yes or no? So how can we write friction force? And let's suppose from this side force is acting, that is NB. Clear? This is a normal force, or we can say any action force that is exerted by block B on A. Clear? So first I will calculate here friction. So friction value is given by mu times of, I can say, MAG. Yes or no? Mu times of n. Value of mu is given 0.15. Mass of block A, this is given to you 5 and multiplied with 10. Clear? So I can say this is 50. So 15 upon 100 into this is 50. I can say this is 2. So this value we have 7.5 Newton. Clear? So because we can say this system is at rest, so there is no acceleration. So now I can write like this, NB plus F, this should be equal to 200. Clear? Now we know friction force is 7.5 Newton. 7.5 Newton. So we can see NB plus 7.5, this should be equal to 200. Clear everyone? So now we can write like this, NB, this is given by 200 minus 7.5, and from here we can see this is equal to 192.5 Newton. Clear? So I can say this is a force exerted by block on block number A. Clear? Same we can say same force is exerted by A on block B. Clear? So from here you can say if we talk about reaction force, this will be 192.5 Newton. Clear? Now next part is given to you, what will happen when we remove this partition wall. Clear? So if we remove the partition wall, clear, what will happen? Let us try to understand. Now we know actually we are applying some force 200 Newton, and let's suppose if we are taking A and B as a system, I can say we have already calculated friction, this is equal to 22.5 Newton. Clear? And let's suppose if we remove this partition wall, definitely we can say this system comes into motion. Clear? Or we can say some acceleration will act. Clear? So now we can write like this. Let's suppose here we have block number A, and let's suppose here we have block number B. Force acting in the right direction 200 Newton. Friction force is acting, this is equal to 22.5 Newton. Clear? And let's suppose acceleration is acting in the right direction, this is A. Clear? So I can say we can write like this, 200 minus this is equal to 22.5, this should be equal to total mass into combined acceleration AC. Clear? So I can say 200 minus 22, this is equal to 178, or we can say 177.5, this is equal to total mass. Total mass we have 5 plus 10, this is equal to 15, and acceleration is AC. Clear? So from here you can calculate acceleration of these blocks. This is given by 177.5 divided by 15. So we can say this is 1, we have 2 left, again we have 1. Clear? We have 12 left, and we can say almost 11.7 meter per second square. Clear everyone? Again you can say 15, we have 2 left, again we have 15, we have 12 left, and we have 8. So 11.8 approx we can say meter per second square. This is the acceleration of a system when we remove this partition wall. Clear to everyone? Done. Now if we talk about what will happen, this is clear to us. Yes, if we talk about what is the normal force, or we can say what is action reaction force, this is acting between block A and B when both are in a motion. Clear? So I can apply, I can draw here free body diagram of any block. Let's suppose if I am drawing for block number A, I can say this is 200 Newton. Clear? I can say acceleration is A. Clear? Friction force is acting, this is 7.5 Newton, we have already calculated. So now I can write like this, 200 minus 7.5, this should be equal to mass of this, we can say mass of this block, we can say that is 5. Clear? Actually our objective here is to calculate normal, so I can say let's suppose this is NB also. Clear? So we can say this is minus NB. Clear? And it should be equal to, now we can say what is total mass of this block A, this is equal to 5, and acceleration we calculated just now, this is 11.8. Clear? So from here you can say this is 192.5. Clear? And I can say this is minus MB, and this should be equal to, we can say this is 0, we have 4, so this is 59. Clear? So from here I can say reaction force, or we can say force exerted by B on A, this is given by 192.5, and this is 59.0. Clear? So I can say value of NB, this is given by 5 point, we can say here we have this is 3, we can say 8, this is 133.5 Newton. Clear? So I can say this is a reaction force exerted by B on A, and we can say same reaction force, same action force is exerted by A on B. Clear? So actually when we remove a partition wall, at the time full system, this total system come into motion, and we can say this will move under the combined acceleration A, because external force exerted it is greater than compared to the friction force acting between block and surface. Clear? So we have calculated total acceleration. After that we also calculated here normal reaction force, and definitely you can say this decreases. Clear? So my dear student, this is all about this question. Hope you understand this question. Clear?